All right, so let's just get some practice with finding equations of lines in 3D. I've got our vector, parametric, and symmetric forms of the equations of a line down in the bottom right corner in that red box, and we're going to find all three of them for this line, which is described to us as the one passing through 2, 3, 1 in the direction of -1, 1, 2. Okay, so they have given us the point 2, 3, 1. That's going to be the P. That's your x naught, y naught, z naught that's going in right there in your vector equation down there. And then the vector is your direction vector. That's your ABC. That's going to go right there. Okay, so the vector form of the equation line with the point and the direction is very plug and chug. So we're just going to copy down that top formula that says x, y, z is equal to x naught, y naught, z naught in vector form, not in point form. So 2, 3, 1. And then plus a t times ABC, so -1, 1, 2. And that's the vector form of the equation of line, so easy peasy. All right, so you can plug into those parametric equations with the x naughts and a's, b's, and c's and all that, or you can just remember that this is equating the components, the x, y, and z components of that vector equation that I just wrote down. Okay, so the x bits are equal to each other. X equals x naught, let's see, plus t times -1, so that's going to be minus t. All right, my y equation is going to be equal to the y component of that vector 3, that's y naught, plus t times 1. Again, I'm just distributing this t through that direction vector. And then z is equal to z naught, which is 1, plus c times t, so plus 2 times t. And again, those three equations together describe the line. You need all three to have the parametric equations. And then the symmetric equations, you are doing this bit down here. Okay, this is solving the parametric equations for t and setting them equal to each other, or you can just kind of plug straight in. X minus x naught divided by a equals y minus y naught, which was 3, divided by b, which was 1, and then z minus z naught, which was 1, divided by c, which was 2. All right, and really in the x part and the y part, you could really easily simplify that -1 and the 1. I kind of like to leave it like this because if you leave the symmetric equations with those numbers in the denominator, then you can just look at the equation and see what the direction vector was, the -1, 1, and 2. Same thing with the parametric equations. I can see that the point was 2, 3, 1. That's that kind of first column of the parametric equations. And then the direction vector is sitting there in the coefficients of the t's, -1, 1, 2. All right, let's try one more. All right, so let's find the vector, parametric, and symmetric equations of the line passing through these 2 points. All right, so instead of giving us a point and a direction vector, they've given us 2 points. We know how to find a vector between 2 points, so it's just one extra little step, calculating that vector. Our x naught, y naught, z naught that we need for all three of these formulas can be either one of these 2 points. They're both valid choices. Your answers will look a little bit different if you decide to pick the second point and I do the first point, but they will both describe the same exact line in R3. All right, so I've got my points. Let's find our direction vector. That's just going to be the vector between these 2 points. And honestly, this is the one time it doesn't really matter whether you do PQ or QP, you'll still get the same line described in R3. But I'm going to kind of stick with the way we usually do this, and right minus left. So I'm going to say 1 minus 2, y coordinates 3 minus a -1, z coordinates -1 minus 2, -1, 4, and -3. All right, so that's our direction vector. That's going to be our A, B, C. All right, so let's write down our vector equation of the line. This is exactly like the last problem now. So we're going to say x, y, z is equal to x naught, y naught, z naught, plus t times our direction vector ABC. So that's the one we just found. All right, just plugging and chugging into that red box, formula box down there on the right. Our parametric equations, x equals x naught plus t times -1, so minus t. Y components, y naught is -1 plus b times t, so 4 times t. And z naught was 2 plus -3 times t, so minus 3t. And again, all three of those equations belong together as the parametric equations. And then symmetric equations plugging in, same idea. So we've got x minus x naught over a equals y minus y naught, so minus a -1 over b, which was 4, z minus z naught over c, which is -3. And again, I don't like to simplify symmetric equations. I don't like symmetric equations in the first place, but I don't like to simplify them because they leave that direction vector sort of out there for everybody to see. All right, so that's how you find equations of lines in R3. We're going to do more with them when we meet together in class.